Hey guys, how's it going? My name is Preston. I'm so excited to share with you something that I absolutely love. Before I get into it, let me introduce myself a bit. Like I said, my name is Preston. I'm a mechanical engineering student at Brigham Young University, Idaho, and I absolutely love it here. Going into my junior year, um, what got me interested in mechanical engineering is actually a class that I took in high school. Well, a series of classes where I got to learn a little bit about design. Um, they were like preparatory engineering classes for college. And I'm sure since you're here taking these classes, you have some sort of interest in engineering or math or physics or something related. And I'm excited to help you kind of discover those passions or help you work towards your goals. Um, that's that's what a lot of people did for me when I was your age, and so I'm excited to be able to do the same for you. Another cool thing about me, I actually lived in Argentina for 2 years. I speak Spanish, and I got to do a bunch of really awesome stuff down there. Like we got to do service projects. I taught an English class, and I'm always willing to share some fun adventures of my time down there. So as you get to know me, feel free to ask about that. But let's get into it a bit. What I wanted to talk about is a subject that I absolutely loved in high school. I quite enjoyed my math classes, and there was one that I didn't know anything about until I actually got to the class, and that was calculus. And I'm sure some of you are probably taking that right now or are about to take it. So I just wanted to go over a brief review of what calculus even is and one of the main problems that it helps us to solve because it is so useful. I use it literally every day as an engineer, um, and it's not something that's as scary as it sounds. I know when I started, I just heard from my friends that it was a big class that was really difficult, and I quickly realized that maybe at first there's some new principles, but it actually makes math a lot easier once you start figuring out like what it means. A lot of the formulas and different things that you learned in your geometry class, your algebra class, actually come from calculus. So you're finally going to know where these things come from and be able to apply it, not just for the sake of math, but also in real world applications, being able to solve difficult problems. So calculus actually helps us to solve two main problems. I'm just going to go over the first one, and it's related to something that you've definitely heard of before. It is called slope. So I'm going to go for a quick, brief review of what slope is. Let's say we've got an equation for a line that should be familiar, y equals mx plus b. And if not, that's okay, that's why we're going over it right now. Let me just draw a quick line. Here's a graph, y-axis, x-axis, a line. And the way that this equation relates to the graph, b represents where the line crosses this axis. We'll say that's 2. And m represents the slope. And that's what I want to focus on right now. So the way that I learned how to calculate slope is that it's the rise over the run. We take 2 points on the line. Let's say that this is at 2 and 4. And what we do is we count up and over to the other point. So let's say that we start here at the y-axis where x equals 0 and y equals 2. We go up 1, 2, rise 2, over 2, 1, 2, run 2. So on this line, the slope would be 2 over 2, also known as 1. And what that basically means is that as x goes up by 1, y also goes up by 1 on the graph. And this is just a series of points that are increasing by x equals 1, y equals 1 over and over again to form a straight line. And that concept of how x and y are changing has everything to do with calculus. So a slope, another fancy way of saying slope, is the rate of change. And in the real world, one example of rate of change would be speed. Like if you're driving a car. If you're driving a car, we usually read the little speedometer that says miles per hour. Or in other words, it's saying how many miles am I going related to how long it'll take to go that distance. Let me give you an example. Let me draw something for you. So let's do a real world example of how rate of change could be applicable. Let's say we've got our best friend Jimmy, who's at his house, and he needs to go to school. Let's say his school is really far away. We'll say it's 10 miles away. Here's his house, here's his school. Write school up here. His house is at 0, school is at 10, and he's got to go all the way to school. And Jimmy, in his travels, he starts at home, he starts going to school, but when he gets halfway, he realizes he forgot his backpack. So he has to turn around, come all the way home to grab his backpack, and then he realizes he's going to be late for school. So on the way back, he runs all the way to school. Okay? So we're going to describe this with a graph. So let's say we'll draw a graph, and instead of saying that this is x specifically, we're going to say that it represents time. So we're going to draw a line that represents where he is in relation to the school compared to time as it's passing. So we're going to put a t right here for time. So he starts at home, and as time goes on, he's going up, he's going closer to the school, gets halfway, turns around. Time keeps going forward, he's coming home, he gets home. And then for this last part, he's going to run to school, so it's going to take a short amount of time to go really fast. So the slope of the line is going to be a little bit steeper. So he's going to go run, book it to school, just to barely make it there in time. And let's take a look at this now. Let's put some numbers on here. Let's say that it's really far, it's 10 miles. I hope that you don't have to walk that far to school. But let's say that right here is half a mile. Here's another half a mile, so we're at 1 mile. And right here is hours. Half an hour, 1 hour, and right here's an hour and a half. And right here's halfway, so that's 5. Okay, so if we take a look at this, we can actually know how fast Jimmy is going in each part of his journey based off the slopes of the lines. Because the slope is rise over run, or part of the y-axis divided by the part on the x-axis. And we have this defined as a distance. We'll say it's miles. So the rise for this part of his journey, when he's walking, let's say it is 5. So the rise is 5. And we go over, it took him half an hour. So the run would be 1/2. So that's 5 miles divided by half an hour, which gives us 10 miles per hour, which is speed. So we can see that one way to represent speed is by the slope of the line on our graph. That's one way that slopes are really useful. Well, 10 miles per hour is really fast. He would probably be running, but this is just an example. So let's take a look then at this part of his journey where he's running. We should expect it to be faster. The slope is steeper, which means that he's going to be running faster. Take the rise, which is going to be 10 divided by, or 10 miles, divided by the run, which is another half hour, which will give us 20 miles per hour, which makes sense. He's running twice as fast to be able to get to school on time. That is super fast. Jimmy is an Olympian, but like I said, it's just an example. Now, realistically, in the real world, Jimmy probably didn't run the exact same speed the whole way to school. I know that if I ran that far, I'd probably start out running and then slow down and probably walk towards the end because I'd be so tired. So if we wanted to draw what it actually looks like, it might look more like this. Starts out steep and then gets slower and slower and slower and slower until we get almost flat because he stops when he gets to school. And this is a bit more realistic than a description of what Jimmy's probably going through. So what we want to know is how fast is Jimmy going at any particular part his journey. And that's what calculus allows us to do. One way that we can find like an average estimate of how fast he's going during his journey is by picking 2 points on the graph and doing the same thing we were doing before. So we'll take this point right here and this point right here, and we'll draw a line that will approximate that curve. See how the line is almost laying exactly on top of the curve? Well, what we can do is calculate the slope of that line, and it'll give us like a rough estimate of the average speed that he's going. But what we want is exactly how fast Jimmy was going right at that spot. How fast was he going right at that moment in time? At an hour and a half, how fast was Jimmy actually running or walking? And what calculus does is it takes this formula that we use to find rise over run, which is y2 minus y1 over x2 minus x1. Or in other words, we take the rise, the y position at this point of his journey, minus the y position at this point, divided by the x position at this point, by the x position at this point. And if you see, if we want to get a more accurate description of how fast he's going, we can just move the dots a little bit closer together. So let's say we put the dots here and here, and now you can see the slope is even closer to being the same as the slope at this specific spot on the line. What we want to do is draw a line that exactly just barely grazes the curve. And if we do that, draw a line that just barely grazes the curve, if we find the slope of that line, it touches right there. And if we find the slope of that line, it'll actually tell us exactly how fast Jimmy is going right at this point. And this concept works in all sorts of different things where things are changing. Right now we're talking about speed, but it can apply in all sorts of different ways. And we can find the slopes of all different kinds of curves. And what we're doing is as these lines get closer and closer together, these numbers, the difference between these two dots is getting closer and closer to being 0. Once they're touching, the difference between them is 0 because they're on top of each other. And that's a problem. Because if the difference between the two dots is 0, then our equation says that we're dividing by 0, which is a big no-no in math. We're not allowed to do that. It's actually not possible. So what do we do about that then? That's where the big concept in calculus comes into play. It's something called a limit, which basically means instead of actually calculating what the difference is, we're just going to take a look at where it looks like the two dots are going. Let's just call the difference between the dots a change in x. So it's just the difference between them, how they're changing. They're getting closer and closer together. And as that number gets close to 0, then we'll actually be getting close to this line. But we're not actually going to hit 0. We're just going to get super, super, super close, infinitely close, until we're practically at 0. And that's what calculus is going to allow us to do. It's going to allow us to take what's called a limit, where we describe things that get super, 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 super close to 0 without actually touching, so that we don't break this rule of you can't divide by 0. And it'll actually give us the solutions to these seemingly impossible situations where we would otherwise have to do that. And to go into the details of other examples and how we take limits, other examples of limits, we'll probably save that for another class. But now you've got an idea of what calculus is going to help you do. It's going to help you to find the slopes of curves of all different types. You probably know about, there's parabolas, there's sine curves, there's all sorts of different graphs that you've learned how to do, and you're going to find out how to find the slope of those graphs at any point on the graph. And when we have situations in real life that are described by that graph, we can find out the relationship between what those graphs represent. And that's kind of the first big principle, first big concept that we learn in calculus. And you probably have some questions because it's new. Just let me know and I'll be free I'll be more than happy to help you kind of get your head wrapped around it. But this is kind of my intro into the first big principle of calculus.